In my last lecture, I talked about flooding. In today's lecture, I'll talk about distance vector routing algorithm, which is one kind of dynamic routing algorithm. In this, what happens? It considers all the routers and network as a graph. A graph is a set of nodes and edges. In this, BELLMAN-FORD algorithm is used to find the shortest path between nodes. According to BELLMAN-FORD algorithm, the shortest path between source and destination is calculated based on the given cost of the edges. Let's try to understand this algorithm. According to BELLMAN-FORD algorithm, what happens here? We have some nodes here, A, B, C, D and E. Now, if A to E, we need to transfer some data, then what are the possibilities of reaching to E from A? From A, we can go to C, and then from C, we can go to E. In that case, the cost will be 5 plus 4, 9. From A to E, we can have our journey through C. From A to C, then C to E. In that case, the cost will be 5 plus 4, 9. We can achieve our target through another route, that is from A to B, then B to C, then C to E. In that case, the cost will be 7 plus 4, 11, 11 plus 4, 15. Therefore, the shortest path will be A to C, then C to E. So this path will be selected. In BELLMAN-FORD algorithm, this way the shortest path is calculated and selected. Let's see another example to understand this BELLMAN-FORD algorithm. Here you can see, say I is the source and J is the destination. In between I and J, many other nodes are there. Say node 1, node 2, this way till node n. Now from node I to node 1, the cost is Ci1. In the same way, from node I to node 2, the cost is Ci2. This way, from node I to node n, the cost is Cin. Here from node 1 to destination J, the cost is D1J. Here from node 2 to destination node J, the cost is D2J. And this way, here from node N to destination node J, the cost is DNJ. Now we need to find out the shortest path between node I and node J, as I is the source and J is the destination. So destination Dij will be the minimum of Ci1 plus D1J, this way till Cin plus Dnj. In distance vector routing algorithm, cost is normally hop counts. What is this hop? Hop is the number of networks crossed. Let's see this. Say here we have some nodes, node A, node B, node C. Node A is a network, node B is another network, node C is another network. The cost between A and B is 1. The cost between B and C is also 1. Now, in case of hop count, from A to C, number of hops will be 1 plus 1, that is 2. In distance vector routing algorithm, each router maintains a routing table, and each router needs to update the routing table asynchronously. When it receives information from its neighbors, that time it updates the routing table. After updating the routing table, the result is sent to all the neighbors. In this diagram, you can see that we have 4 nodes. This is router A, this is router B, this is router C, and this is router D. Now source is A and destination is D. So when the data will reach to the destination, that time this route will be completed, so it will be discarded, and the information related to this data transfer will be informed to router A, and according to that, router A will update its routing table. In this algorithm, each router should keep at least 3 pieces of information for each route. One is a destination network, another is cost, another is next hop. In this diagram, you can see that router A, router B, router C and router D, these 4 routers we have here. So each router maintains a routing table, and minimum 3 pieces of informations will be there. Say this is the routing table of router A. If A is the source and D is the destination, then in A router's routing table, destination column will get D because D is the destination, and from A to D the cost will be 1 plus 1, 2 hops are there, so 2, and next hop is B. That means through B, router A is going to send the data to router D. This way, each router must maintain a routing table which consists of minimum these three pieces of information: destination, cost, and next hop. Two pieces of information is received during updation, that is a destination network and the cost. Here next hop is the source. What does it mean? It means, say A is sending data for router D. When router D will receive the data, after that router A will update its routing table according to the information received from D. So router D will send some information to its neighbor, that is router B, and further router B will send the information to router A because A is the neighbor of router B. Now in this case, when B is sending information to router A, that time destination is router A and the cost is this, and the hop is the source. Next hop is the source because A was the source. When a record arrives, the router searches for the destination address in the routing table. If the entry is found, if the record cost plus 1 is smaller than corresponding cost in table, it means neighbor has found a better route. Let's see this diagram. Say this is router A and this is the source, and this is router D, this is the destination. Now router A is maintaining a routing table. Say this is the table. Now in router A's routing table, destination is D. Now if router A sends the data through this way from A to B, then B to C, then C to D, then the cost will be 1 plus 1 plus 1, 3. And the next router will be, or next hop will be B. But if A sends a data through this way from router A to router E and router E to router D, then destination is D but cost will be 1 plus 1, 2, and the next router will be E. So here the better one is the second one where the cost is less, therefore it will be selected. If the next hop is same, it means some changes has happened in some part of the network. What does it mean? Let's see this diagram. So here A is source and D is a destination. If A sends the data from A to B, then B to C, and then finally C to D, then the cost will be what? 3. 1 plus 1 plus 1, 3. And if it sends the data through router E, then the cost will be 1 plus 1, 2. Now when the data will reach to the destination, then this route will be cancelled and the cost here will be replaced by infinity. Now this time when A will update its routing table, that time this entry will be there that through E, if it sends the data to D, then the cost will be 1 plus infinity is infinity, so it will be infinity. So another entry where destination is D, cost is infinity, and next is E, that will be recorded in the routing table. Now in both the cases you can see that the next router or next hop is E. So it means some changes has happened in some part of the network. If the entry is not found in the table, then the router adds it to the table and sorts the table according to the destination addresses. So what is that? Say in this diagram we have these routers A, B, C, D and E. In the last figure also you have seen these routers. Say one more router we have here, that is F. If the record of F is not there in the routing table of router A, then that record also will be added. So when router A will update its routing table, that time it will enter there that there is a path from A to E and E to F. Now let's see one example. Say we have these routers A, B, C, D, and here A is the source and D is the destination. Now what happens in case of router A's routing table? Router A can send data to D through router C or through router B. If router A sends data through router C, then the cost will be 23 plus 5, 28. But if it sends the data through router B, then the cost will be 3 plus 2, 5 plus 5, 10. Now in router A's routing table, say the destinations are A, B, C, D, and here we have the routers A, B, C, D, so this is a kind of matrix. Now when router A will send to router B, that time the cost is 3. When router A will send to router C, that time the cost is 23. When router A will send to router D, that time the cost will be through B, it will be 3 plus 2 5 plus 5 10. So destination is D, and through B as it is sending, therefore the cost will be 10 here. Now through C, if it sends data for D, then the cost will be 23 plus 5 28. So destination is D, and as it is sending data through C, therefore the total cost is 28. So all these things will be recorded in the router A's routing table. Router A receives an update from router B. What kind of update? This router B, will say router A that from B to C and C to D it has a path and the cost is 7. So this way the routing table of router A will be completed. If A needs to send to B, the cost 3 will be selected. If A needs to send to C, then cost 5 will be selected, because this is the shortest path. 3 plus 2, the cost is 5, but here it is 23. If A needs to send to router D, then definitely cost 10 will be selected, because through C if it sends, then the total cost will be very high, that is 28. In the same way, the routing table of B, C and D also will be formed. I hope this is clear to you. Okay.